Hello and welcome. In this video, we'll talk about a new CashScript release, version 0.10.0, which just came out yesterday. So these are the full release notes. You can see it's a big upgrade. But to get started with the overview, we'll use the thread on X to cover everything, the big items, the new features which were added. So let's go over them, and then we'll discuss them more one by one. So first, local evaluation and testing. Second, Console.log statements. Custom require error messages. Also, BitAuth IDE debugger integration. And lastly, but not least important, is fully overhauled documentation. So if you still need to delve into CashScript or want to learn, now is the best time to do so because we put a lot of time into making it much more accessible for new developers. Yeah, let's talk about the features one by one. So first, the local evaluation and testing. When debugging your contracts, it can be very helpful to run your transactions locally rather than having to use a test network. This allows you to test your smart contracts even when you don't have an internet connection or a testnet Bitcoin Cash. And there is an additional reason. If you send a transaction to a network and it fails, you will just get a generic error message back. Whereas if you validate it locally, then you will know exactly where the transaction failed. So you have much better information to debug with. So we'll take a look at this this code snippet of how you would use this local evaluation to test your smart contracts. So here is an example of how you would do this. You import some things from CashScript, and then you also import the new CashScript jest extensions. So this is the testing framework by CashScript, the extensions that we'll use in the rest of this snippet. And then you can see we have one testing block where we start a mock network provider, which means we evaluate the transactions locally. We create UTXOs out of nothing because it's a local testnet setup, so we can just do that. And then we have 3 tests that we want to run, which always start with it. So it should log the passed parameter. In this test, it should fail the require statement when an incorrect parameter is passed. And here it should pass the require statement when a correct parameter is passed. So if we delve into each of these blocks, you can see here for the logging test, it expects the transaction to log passed parameter equals 1000. Here it expects the transaction to fail a require with passed parameter is not 1000. And in this last test, it expects the transaction not to fail a require at all. So this way you can test all the edge cases in your smart contract and be confident your transaction works as you expect. Next up, the second feature is the console.log statements. When you're running your contracts locally using our node tooling, it's now possible to log values during the execution of your smart contract to better understand what is happening. So if we again take the example of the same example where we log a parameter value. So here we pass the value to an example function, and then we see console.log passed parameter is the value, and then it requires that this value is equal to 1000. So it's just a simple example contract. Sometimes a lot of advanced computations happen on the stack, so it's helpful that you can console.log intermediate values, or if a check fails but you're not sure why, you can use this new console.log functionality to better understand why your require statement failed. Then the third new feature is custom require error messages. Similar to console.log statements, custom require error messages make it much easier to understand which require statement is failing. So this is the same example, and here the custom error message is of course passed parameter is not 1000. So you can just pass in a human readable error message, and should this check fail, which of course is in code, so it's a bit harder to parse sometimes, then you can have an easily readable error message. Then about the fourth big item, the BitAuth IDE debugger integration. So when console.log statements and custom error messages are not enough, we have also added an integration with the BitAuth IDE debugger for low-level debugging. So this is a screenshot. Let's take a look. And here we see a CashScript contract on the right-hand side, namely the transfer with timeout contract. And on the left-hand side, we can see the compiled opcodes. So each of these lines, this is two-way mapping. So each of these lines of the CashScript code translates to the opcodes we see on the left-hand side. And this is what's actually broadcasted on the Bitcoin Cash network. So this is how the Bitcoin Cash VM evaluates transactions. So if there is any really weird behavior or error happening, you can go to this low level and understand what is happening under the hood, how your require statements are translated into opcodes, and this can help you debug or better understand what is happening under the hood. And then the last major item is the overhauled documentation. We have fully overhauled the documentation to make it easier for beginners to get started using CashScript and to get started using the new debugging and testing tools. So if we take a look at this documentation, you can find it on cashscript.org, and it features a few different aspects than before, namely the TypeScript SDK, the familiar syntax of the CashScript language, the integrated network APIs, and the advanced debug tooling. So this is what we're talking about today with, for example, the testing suites that it enables and the integration with the BitAuth IDE. So this showcases the major benefits of using CashScript for smart contract development on Bitcoin Cash. And then if you press Get Started, you'll see the Getting Started guide has also been fully reworked. So first it features the CashScript playground where you can try CashScript online. And then it helps you with the prerequisite of getting set up with CashScript. So of course a code editor, Node.js, and a basic familiarity with the command line is recommended. And then it walks through step by step how you can get started compiling your smart contract, creating a CashScript transaction with first installing the SDK, then initializing a contract, and so forth. So if you follow this, at the end, you will have successfully created a transaction spending from a Bitcoin Cash smart contract. So I think this will be very helpful for people trying out CashScript for the first time. There's also a new section about Bitcoin Cash, which talks about the UTXO model and how smart contracts work on Bitcoin Cash, an introduction to Bitcoin Cash script, as well as why CashScript is such a nice abstraction. So if we close this section about the basics, then there's now added documentation here in the TypeScript SDK about the testing setup and also in the guides about debugging. So let's first take a look at the testing setup. As it says here, the testing setup is currently, it only works with the simple transaction builder. So if you use the advanced transaction builder, we still have to extend the debugging toolings to work with the advanced transaction builder in the future. And like we saw before with the testing setup, here it also explains everything step by step. So how you would use the mock network provider, how you can just create UTXOs, and how there are helper functions like random UTXO or even random NFT, random token for testing. How you can write automated tests using the jest extensions, how you can use logging values with the expect.toLog, and here you can use expect to fail require with or not to fail require with. And here there is a full example of how you would write your own testing suite or testing setup for your smart contract transaction. There's also new examples here in the TypeScript SDK. So if you want to learn how to use the TypeScript SDK for a more complex project, here it walks through step by step how you would use it to create a HODL Vault application. So it starts from the HODL Vault smart contract, the HODL Vault.cash, and then it walks through how to create the key pairs, how to generate a contract, how to build the oracle, and finally how to send a transaction. And for this, it uses libauth, so you also learn a bit how to work with other Bitcoin Cash libraries. You learn how to set up your contract using ChipNet, and how to create the contract address. And then here how to build the oracle, and finally how to send the transaction. So you can see here transaction.send. So this is a pretty comprehensive example, and it covers a few different aspects. So this is also new and can be very helpful. And then lastly, what's important to cover is here the debugging guide. So the debugging guide, if you are using the simple transaction builder, is mainly what we've covered today. It's the error messages, console logging, and the BitAuth IDE. But should you still be using the advanced transaction builder, which does not have access to these new features, then there's also some help here. So how you can, about the strategies for debugging you are left with. So you can use the failing opcode, you can remove contract checks, or you can make a contract with a single check. So this can be very helpful for anyone stuck with debugging. And then the releases, so this covers everything in detail. There were a few breaking changes. So should you have used any of these, for example, these transaction errors or these typings which were exported, they have now been reworked. So you can take a look at the migration notes, which tell you how you can update your application. And one more thing we added is here in the showcase. It now features some new applications which have been built with CashScript. So of course, AnyHedge, TapSwap, Bitcat Heroes, the Cash Ninjas, BCH Guru, now also the Cash Token Studio, and the new Badgers.cash application for staking and also for minting NFTs. And then BCH House and Unspent Fi. So the list of applications built with CashScript keeps getting longer and longer. And yeah, we're very proud of that. And of course, we will continue developing and improving CashScript in the future. So thank you all for watching this video. Hopefully you can take a look at the new documentation, because we really put some extra effort into it. And see you all in the next video. Bye bye.